Nets and drawings for visualizing geometry. Objectives: to make nets and drawings of three-dimensional figures. Essential understandings. A net is a two-dimensional diagram that you can fold to form a three-dimensional figure. A net shows all of the surfaces of the figure in one view. Example 1. The net at the right folds into a cube shown beside it. Which letter will be opposite the letter C? Well, let's look at that for a moment. Here's our net. It starts off, and I've labeled these A, B, C, D, E, F, just like you've seen. And I'm going to make the cube. These are going to be available for you to manipulate while you're doing your homework, but you won't have them for the test, because you'll get better at it by then. Notice as I start to fold this up, it starts making the cube. Now right there is C, and opposite of that would be the letter A. And I could close this shut and we can see it on both sides. Here's A, opposite of that is C. Now some of you will be able to visually do this in your mind, others of you will need a little bit more hands-on for practice until you can get to that ability. Seeing that short little fold up, we can see that opposite the letter C is going to be the letter A. Okay, it says, what is the net of the box to the right? Well, if we start unfolding this, notice how it wraps around the base right here, and it does the same thing over here. We'd have a rectangle. And the nice thing is that the base is a square, so each of them are equal. And to draw that more accurately, I'm going to divide in half and divide in half again. So these are each 2 units long. This is what's wrapping around the base. These links right here. And then I'm going to have the base. Now, the great thing about nets is you and your neighbor could both draw them a little bit differently. Someone may, and by the way, this is 4. Some of you may draw your net to look like this. And say that this is 2, 2, and 2. That would be one net for this. You could also rearrange this, and if you take the bases here, you could move them to each one of these different locations, and it would be the same thing. Or you could have one in this location and one over here in this location. There's actually, I think, 6 nets that would accurately fold up into this box. So that's what you're looking for. An isometric drawing shows a corner view of a three-dimensional figure. It allows you to see the top, front, and right side view. You can draw an isometric drawing on isometric dot paper. It shows a 3D figure using a slanted line to represent depth. Okay, it says, what is the isometric drawing of the cube structure at the right? And we're going to get some practice with this. I've given you some isometric dot paper on your fill-in-the-blank notes. So the first thing you want to do is probably represent the depth. So I'm going to represent this length right here. I'm going to come over here and say I need it to be 3 units. So 1, 2, 3. Okay, then I like to draw the top in, so that way I know what I'm working with. So I'm going to make my top, and I know that it's going to go 2 units down on both sides. So I'm going to draw 2 units down, 1, 2, 1, 2, and then I'm going to have another top. And I also know that this is 1 unit on each side. And then I'm going to connect my dots. And some of you may like to draw those in so that way you can see that it looks exactly like this figure over here. Others of you might want to leave it. Now guys, if you struggle with this, that's okay. A lot of people, either they're getting it and they're making these elaborate drawings, and some of you will sit there and go, oh my goodness, that was awful. It's okay. This takes practice. People who are really good at art find this probably really easy to do. People who struggle with art and seeing that 3D on a 2D paper will struggle with this. This is one of those things that we'll be using to be able to see figures, but I'm not going to be asking you to draw these over and over and over again. An orthographic drawing is another way to represent a three-dimensional figure. It shows the top, front, and right side view. May take more time to analyze. It provides unique information about the shape and structure. It says, what is the orthographic drawing for this isometric drawing at the right? We're going to actually make this shape right here out of cubes that link together, and so that way we can see what the top, front, and right side view would be. Okay, I've made the isometric drawing out of cubes that you can see right here. Okay, now it said that this was the front and this is the right side. So here's our figure, if you want to see it from the view that they've shown, something like this. Now if I want to draw the top view, notice when we talk about the top view, we won't see any depth. And so we would say that the top view is actually this rectangle right here. That's what we would see from the top view, and we would indicate that there's 3 units of the depth. Okay, now we need a right side view and a front view. So the right side view, if we look at this from the right, we're going to flip it over, and we're going to see something like this. We're going to see that stair step. Cut that little knobby off. And there's our right side view. Okay? Now we want to see let me erase this real quick. We want to see what we would see from the front side view. And from the front, I'm going to tilt this over, lay it on its front. Notice we're not seeing a lot of change. It's going to still be another rectangle. And again, having 3 units long. That would be the front side view. To put this as an answer, we would say this is our front view. Ugh, okay, obviously art's not my thing. A right side view. And a top view. Now notice that doesn't show any kind of depth that we can see. It's just what you would see if you look straight at it from quite a distance, so that way you don't see any depth perception to see in the front. We would just see the 3 cubes. We're not seeing the depth that one is 3 units out right here, closer to us than this one right here. Okay?